Finding the derivative of trig functions. Here is the graph y equals sine x, shown with a blue line. It is drawn for the domain 0 to 2 pi. The derivative of a set of points on the line y equals sine x is found and plotted with a red scatter plot. Have a look and see what happens to the shape of the graph. The new graph has the same shape as the graph of cos x, so the derivative of sine x is equal to cos x. The graph of cos x is drawn for the same domain as the graph of sine x and has the same period. The next graph we'll look at is the graph of y equals 2 sine x. This is the sine graph with an amplitude of 2. The graph is drawn with a blue line, and a series of points to find the derivative of 2 sine x are plotted with a red scatter plot. Look at the shape of the new graph. We see that the derivative of 2 sine x is actually equal to 2 cos x for every point along the curve. Let's consider what we've noticed. We've found that if we look at the graph y equals sine x, its derivative is cos x. And if we look at the derivative of y equals 2 sine x, we find out that its derivative is 2 cos x. Now let's try and generalize that. We'll use a for the amplitude. So when we have y equals a sine x, the derivative dy by dx is a cos x. Let's have a look at the derivative of 3 sine a half x. Here is the graph y equals 3 sine a half x. Once again, the red scatter plot will represent the derivative function. So the amplitude of the sine graph is 3. The amplitude of the derivative function is definitely 1.5 or 3 over 2. Both graphs have the same period. So the derivative of 3 sine a half x looks like it is 3 over 2 cos a half x. The derivative of y equals 3 sine x would be 3 cos x. My new function is y equals 3 sine a half x. The derivative of y equals 3 sine a half x is y equals 3 over 2 sine a half x. So the angle hasn't changed, just the amplitude has changed. Let's generalize this and see what we think has happened. The derivative dy by dx is equal to 3 times a half cos a half x. We have used the chain rule here. What we have done is taken the derivative of a half x to get a half. So we have 3 times a half cos a half x. Let's consider y equals 2 sine 3x. The derivative of this would be equal to 2 times 3 cos 3x, which would give us 6 cos 3x. Here we have y equals sine minus 6x. The derivative of this dy by dx would be equal to cos minus 6x, and then we need to find the derivative of what was inside the bracket and multiply the whole function by that. So we can simplify that to be minus 6 cos minus 6x. So if f of x is equal to sine x, then the derivative f dash x will be equal to cos x. And if f of x is equal to sine of g of x, where we have a function as our angle, it means that the derivative f dash x is going to be equal to the derivative of what was inside the bracket times by cos of g of x. Notice in each case the angle does not change. Thanks for watching. I hope you've learned something about finding the derivative of sine x. Next time, I think we'll look at cos x.